All right, I think we can get started with the last session for today. Hello, Radu, just in time. Very good. You're welcome. Have a seat. Yeah, welcome everybody. Good afternoon. The next 90 minutes will be very different to what you have experienced here before. It's not about PV. It's about famous Pontius Pilatus and his impact on the Roman Empire. Gisem from Meyer Burger will talk about him. All excited about it. Then we will learn about intermediate box containers for the European Union. Florian Buchholz from IC Konstanz will handle this very important topic for us. And then we learn about how to prepare spicy dishes with pepperonis or bell peppers. Ronny Bakowski will take care of that. He's with Q-Cells. Yeah, I think it's a great mix, a good distraction from the usual here at the EUPV conference. I guess talking about PV technology and its role for establishing a strong technology basis for manufacturing in the EU is also important. Maybe we tackle that as well. In addition to the bizarre mix of topics, I think we have a great panel. Addition to the just mentioned presenters, we will have Hamed Hanifi from AI Solar. Then we have Gaëtan Maison from the Becquerel Institute and Maria Getziu from the European Commission. Thanks a lot for joining the panel today. Yeah, and I'm Thorsten Brammer. I'm the host of the podcast, The Solar Journey. We just launched a new version with Jenny Chase from Bloomberg NEF today. She's got some interesting views on how the volume for PV production will develop in the future. But there's also interesting people on the show if you're more into technology. Andrew Blakers, Martin Green, they will also appear very briefly, shortly on the podcast. But now, let's not wait any longer. Let's get started with the presentation, and we will start with the intermediate box containers for the European Union. Florian.
I think it's intermediate bulk containers, but starting this one. There you go. I hope you can hear me. So yeah, welcome everyone, and I'm happy to see some maybe slightly tired faces, but I hope we can enlighten the late afternoon of this third day of this conference. And I'm happy to present on behalf of the IBC4EU project, which is one of 3 projects from the same call that all started in 2022. It feels like a total different age when you think about how the industry has evolved and how things have changed. There was a bit of a how you call that? I was a little bit happy looking forward to something evolving in Europe, and I know how things have turned out, but yeah, nevertheless. Let's a few words about the IBC4EU project. We are 17 partners that are funded from all over the continent and even beyond. So we have Kalyon from Turkey and Coprint from Israel that are in the consortium. And we have associate partners from Germany, like Rena LPKF and Centrotherm, but also Toyal from Japan. We are 17 partners. We have a EU funding budget of about 14 million, a total budget of 17 million euros. And what we founded essentially for this call was the EURECA, the European Rear Contact Alliance. So what's it all about? We wanted to use the R&D and innovations that we have among the research institutes and innovative partners to get through the way of sustainable process development, using new equipment and processes to get the technology to pilot line technology readiness level. And first of all, the question, why IBC? What is IBC? It stands for interdigitated back contact cells in this context, and it yields very nice looking modules for all sorts of integrated applications. They are of course great because you don't have the front side metallization fingers, and also you have a very high energy density. And yeah, what's the target markets? I think like any of the newer technologies, it all starts on a rooftop, because I think this is where most of the innovation comes in a little bit earlier than in the big utility scale market. So we hope to be mature. We might be a bit more expensive, but with incentives and in combination with battery storage, it's still very interesting to go for the aesthetically nice modules. And it gets even a better business case when you're looking into building integrated PV, because there the margins are different even further, and there's a lot of opportunities there. But of course, it's also not so easy market, because I mean you have to deal with other people like architects, and so they have other requests, but you have also to fulfill other standards, and there's a missing benchmarks. So what are we talking about from the cell technology side? We are investigating two solar cell processes. One is from ISFH and is currently in a how do you call that, in a due diligence or something with Calion. So they would like to see whether that can be produced in their old PERC line. It's based, a lot of processes are based on the PERC technology, and adding to that the passivating contacts gets you a solar cell as sketched in the bottom and the middle on the right. So the current solar cell efficiency in the lab is about 24%, and they see a potential of getting that to 25%, and using the shadow mask deposition process that they developed together with LPKF and Centrotherm, it has a very lean process sequence. The second technology that we're looking at is the PolyZebra technology. That's a solar cell process developed by IC Constance. And as you can see, it's a both side passivating contact by contact cell, and it has a process flow that is quite close in terms of machines and in terms of process steps to the standard TOPCon process flow. There you can see the tool sets, and you see that it's only three more tools that you would need for making those solar cells. There we have reached 24.1%, and my colleague Jonathan has shown a nice presentation on Monday on how we expect to getting to 25% plus in the near future. It can be piloted in a TOPCon factory. We have a very low breakdown voltage, which makes it interesting for integrated applications, and we have some IP that we have registered and some patents that are pending, which we believe gives us a freedom to operate also against maybe some major threats, as you have heard about, I'm sure, what are currently going around in this industry. And one of the key and unique selling points, I think, is that it's quite simple to get to a very low silver content. We have demonstrated less than 5 milligrams per watt peak silver on a big scale module and showed it already last year at this conference. And therefore, it's since it's all screen printed, it's all based on standard technology. It's a very easy to implement process and has already passed most of the durability tests that are necessary. On the module side, we're looking at a lot of alternative approaches to interconnect the cells. Since the cells are bifacial, we would like to make use of it and give it an advantage, for example, over sun power, whose cells are not bifacially interconnected. And there is an approach by TNO where they have the connection tracks on the glass. We have the standard tabbing stringing that we are employing at IC Constance, and a very interesting 3D multi-ribbon approach by IMEC. And Akira, a Dutch company, they are already a specialist in back contact technology. They are now implementing this into their lightweight back contact module, and it has a lot of advantages, such as it's PFAS free, and they claim to have full traceability raw materials. Another approach is by Value in Finland. They have a very flexible way of interconnecting the cells on any sizes, and can thus deliver customized modules, so to say, for the automobile industry and others. Big advantage of this technology is that it has a very high shading tolerance. You can set it to desired voltage, and you don't need to have bypass diodes. So to summarize, we have some USPs. So we have a secured IP. We are quite flexible in form factors. We can individualize the bombs. It would be EU made, could be integrated. We would like to allow for long-term availability, and therefore that modules and cells might be replaced on the long run. But of course, it's only the first step. We think that this technology is also on the brink of getting cheaper than the standard TOPCon when you're considering the higher efficiency and the lower use of raw materials, of copper, of silver in particular, so that the utility scale market would be the logical next step. But I think that is very similar to what the Chinese have on their roadmap as well. So to summarize, and for an outlook on the topic of today's talk is, can we bring back the production to Europe? According to our partners, of course, it's difficult, but for the IBC technology on the EU market in the EU is maturing. We can make a difference. We have something that is unique. There are some business cases. They might be on niches at the beginning, but of course, niches will be big on the long run when you consider a terawatt market. And of course, as already mentioned, the low-cost IBC have the potential also for utility scale applications. And of course, the strategic importance should be more and more realized. And I think, I skipped through that, this energy security, and that we can, it should be self-explanatory that we cannot rely on a single country to dominate the full market, such an important product as with solar. And because, I mean, you know what has been on the news on the trade measures that were taken by China on pork, on gallium. So it's important enough to work on it and to support it and to get the political will on our side. And with that, I would like to thank you for your attention and hand over.
Are there questions directly to this presentation? Yeah. Well, I've got one short question. You mentioned one thing was that it could be more important than other technologies, but then you mentioned that you use very little silver.
Yes.
So what's then the cost driver compared to other standard technologies?
Why is it still a little bit more expensive?
Yeah.
Okay.
It's not only the material at the beginning, it's also, of course, the capex on the more tools and running a few more steps. So, of course, also adding a little bit to the OPEX. But also the availability of copper paste don't quite translate into the a price difference as you would expect just from the raw material. There's more process steps needed to making the copper paste, and there's only very few suppliers. So they don't come quite as the cheap cost as they could come eventually. So that's one of the things where there's certainly a lot of room for improvement once you get to scale.
Okay, thanks, Florian. We'll then continue with Gisem Nogai from Meyer Burger.
Hello, everyone. And yeah, thank you for being here, and, despite the late time. And so today I will be presenting Platus project on behalf of Platus Consortium. So let's dive in. So Platus stands for actually a digitalized pilot line for silicon heterojunction tunnel interdigitated back contact solar cells and module. So it's not a philosophy. If you can try to find the acronym, but it's a bit difficult. And actually, the name is inspired by the beautiful mountain in Switzerland called Pilatus, that you can also see in our logo on the top right side, the shape of the Pilatus mountain. So the project goal is to prove the scalability of IBC technology that's developed in Europe in collaboration with CSCM, EPFL, and Meyer Burger, based on heterojunction technology. So in the Pilatus project, we have 19 partners covering 8 countries. The project duration is 3 years, and the main goal is to establish 3 pilot lines in Europe dedicated to wafer, cell, and module production. So total cost is above 20 million because we have lots of Swiss partners that is not counted in the European budget. We are having 10 million, approximately 10 million budget from European Commission to realize these pilot lines. So when we designed the project, the goal was to cover all the PV value chain, starting from polysilicon with the associated partner Wacker. And we had the wafer for wafer production, Norwegian Crystal. And during month 8 of the project, which started at the same time as IBC4EU, we learned that we have this unfortunate news about Norwegian Crystal. So it was quite stressful times. But at that point, we also showed a strong collaboration with IBC4EU, because after an alignment meeting, I directly write to Florian to ask if it would be okay that we contact with Norsan to see if some of the tasks that was designed for Norwegian Crystal can be transferred to Norsan. And it was a very nice supporting team there also. We organized, and then starting from month 14, I think Norsan is replace Norwegian Crystal in our consortium to realize the wafer pilot line part. So the cell and module pilot line task is belong to Meyer Burger, so because it's Meyer Burger technology, and we also have other partners that's completing with other activities such as testing of the modules in outdoor, or also like the project is having like a strong focus on digitalization. So we want to establish a traceability starting from wafer to the outdoor monitoring testing of the modules, IBC modules. So we try to cover all these things in the PV value chain. We also equipment manufacturing companies apart from Meyer Burger, like Exatech. We have the process optimization, the partners that helps for process optimization with monitoring and also the inspection. We like ISRA. We have advanced material development that is done mainly with Banana Plus, CSCM, that's responsible of encapsulant development for IBC modules. And also CPT, which is a Cambridge Photonics, that develop photon multiplier films. We have many partners that's focusing on characterization development that will be implemented in the pilot line of the cells and modules, such as Fraunhofer CSP, we have URAC, we have FZU, we have Pazan also, that's developing like an automated measurement system for the pilot lines. The environmental impact of the technology and the production has been also raised and investigated in the project. And this task is taken by University of Liège and TNO, that they perform LCA, like life cycle analysis, recyclability, and also circularity of the technology. And our official coordinator is UniResearch in Netherlands. So the project is composed like we have a one big work package focusing on project management, but one work package is dedicated to establishing a wafer and cell pilot line in Norway and Germany for the IBC tunnel IBC technology. We have one work package dedicated to module pilot line with the capacity of 170 megawatt per year. Sorry, I forgot to mention about the capacity for this, the wafer and cell pilot line. So wafer is the smaller scale, 300,000 wafer production, and the cell pilot line is dedicated 190 megawatt per year. Then we have a metrology and reliability work package that is responsible of all the characterization also that's coming from these work packages. Another work package is digitalization, automation, and work package 6 is more sustainability, and work package 7, bankability and business model, and dissemination work package. So basically, the Pilatus project is composed of 3 pillars: to establish a cell pilot line, the wafer pilot line, and using this wafer pilot line to make cell. So we have the cell pilot line, and then using these cells, making a module, so module pilot line. So there's a feedback in all, while using this holistic data collection approach by using Industry 4.0 tools and the developed softwares. Yes, I can go to the next. So why IBC? I will not explain the advantages of general IBC. Florian already showed very clearly the advantages of interdigitated back contact technology. So in our project, we are using tunnel IBC, and in our point of view, the key advantages of this technology is having a simple and low temperature process. It's based on heterojunction, and we are using a PCVD deposition. So it's really similar to heterojunction process flow, except the fact that we have one step that we need to mask the N layer during the PCVD deposition. And the uniqueness of this technology, not to make like N and P separate, but to develop a tunnel junction that will extract the electron contacts. So the uniqueness of this technology is that layers are optimized in the way that they grow selectively more crystalline on the end contact, so that we have more effective transfers conductivity of the electron contacts, while on the P side they are blocking the lateral conductivity. So it's like a kind of a functional layer. So we also develop advanced masking technology that give us the opportunity to deposit the layer in conformal form. Another advantage of this technology is it's compatible with our smart wire technology. It is developed at Meyerburger, which is basically combining the wire with the carrier foil, so that we can string the cells more easily by using this carrier foil. So it's basically the busbarless technology that gives several advantages of less shading and like more mechanical strength, and also like easy application possibilities. This technology also naturally indium free, so we don't have any indium in the process, in the cell. So if we go through the now, what's the status of our technology? So here on the right side, you can see a nice wet bench that is installed in Meyer Burger Research to prepare the wafers to texture and clean from Exatec. So if you want to know more about it, you can go to the Exatec booth. I'm sure Jerry will be very happy to explain you more detail the machine. So we are at the moment reaching the cell efficiency of 24.8% on half M6 cell size, and we have a target to go larger, of course, because the trend is more on that direction. We also, in the scope of the project, develop an automated cell testing and sorting machine. Here you can see the image of the machine. So it's very, very convenient. So it's not at the moment implemented directly to the pilot line, but it's working very efficiently. Another important parameter, as Florian also mentioned, is the silver consumption. And at the moment, we are in the level of 3.3 milligram. So actually 1 year ago, we were 3.7. So it's quite competitive in the sense. Also, we have like a very low silver consumption. And the target of the project is reached to lower than 2.5 milligram. And we are very, very optimistic about that. And if you look at the current stage for the module performance that we can reach with this technology and the produced cells in the part of this pilot line that they did not, of course, reach the capacity yet, but we can test, is with the 24% efficient cells, we are able to reach the power of 394 watt. And if we now start to use more efficient cells, as I showed before, we expect to get like 10 volt more, and the larger size of the cells, it will also lead us to the main goal of the project. We also did some reliability testing of these modules that has like IBC tunnel cells inside, and compare with our standard heterojunction modules. So all the modules produced with this technology passed at least 4 times ISC requirement, with showing a power degradation less than 5%. They passed the electrical safety tests with insulation and leakage test, and visually they don't show any bubbles or delamination. So we figure out that they are having some power increase when we did some current conditioning that we call, that lead us to get like a CTM loss as low as 1%. And we do that to have like a Pmax plateau to have this stability. And if we compare the reliability of this module with our standard heterojunction reference modules, that is guaranteed for 25 years, we assume that we can easily reach with these IBC modules more than 40 years guarantee. So, as I mentioned also, we have a partner in the project that's working more in the environmental aspect of the technology. So, TNO and the University of Liège, they are performing life cycle analysis and also testing the release encapsulant on the IBC cells. So, the goal is really to have a strong impact on the environmental aspects of the technology to reduce as minimum as possible. So we want to go thinner, use as low silicon as possible, and of course the local production is always the one of the main focus, and reduce silver content, as I mentioned. We are also try to recycle the modules, test the modules that will be 100% recycled, including the silicon material. And the idea is to extract the high value from the model compound at the end of life. So socially, yeah, we want to really design our module in a way that it will be ecological and it will comply with the requirement of the European Commission for the environmental impact. So another aspect of the project is also to evaluate this technology for the other applications. So we have a small task that will be dedicated to demonstrate the IBC roof with our roof tiles, with Meyer Burger roof tiles that you might see maybe in some of the exposition before. We are now having these tiles in the standard heterojunction with the standard heterojunction cells. But at the end of the project, we will make a 1 kilowatt peak demonstration roof, hopefully. So with that, I try to explain you the main activities ongoing in the project. Of course, we have much more. And if you want to know more about the project, you can go to the website and come to me to discuss. Thank you.
Excellent, Gizem. It looks like a very complex project. So many project partners, from feedstock down to the application. All the respect for managing such a huge project. Are there questions? I could take one question directly to the project. You go. Yeah. There's a microphone coming.
Hi, Asad Zawid from BMI, Germany. I want to ask, you said like you're going to move from the M6 to the G12, like the M12 size cells. But you are working on like making now BIPV like as a tile. You don't see this as restriction with the size of the cell to kind of like try to integrate it in a small tile when you go from the M6 half cells to the G12?
So basically, actually, the project in the project proposal, we target to go to M10 size. It was written in that way because back then it was still relevant, and actually the goal is to do the M10 cells, M10 wafer pilot line. But we see more and more that it becomes a bit more obsolete because the sizes are getting bigger. So we are still in the evaluation phase of that. For the tiles. Yes, the size is planned to be M6. Also in Meyer Burger now with the standard heterojunction, we are using M6 half cells for tiles. The frame is designed in that way. So as it is like a small portion just for demonstration to make the evaluation for the feasibility. So at that stage, we keep it like this because it's a demonstration purpose. But if it is very interesting, then of course we need to change the design of the frame to make the roof tile more relevant.
Thank you.
All right, Ronnie, your turn.
All right. Thank you very much for the opportunity to present the Pepperoni project here. First, I have to inform you that I'm just giving this lecture here on behalf of Fabian Fertig, who is actually the technical coordinator of the project, but he prefers to stay on the beach having a cocktail instead of talking to you. So in case you like anything or we have a good discussion afterwards, I appreciate that and take the credits. If you dislike anything or have any critics, reach out to me. I give you the contact directly to Fabian. All right, pilot line for European production of perovskite silicon tandem modules on industrial scale. So I need to start a little bit early and what motivates Q-Cells to participate in such a large project. We still have a very big ecosystem of expertise, experience in Europe, not only on industrial level, but also on academia and institutes. And Q-Cells itself, we still have over 700 employees in Europe and over 220 in our R&D department in Thalheim. So a very large number of engineers and scientists. And so we think we are at least one of the largest cell, module, and system industrial R&D labs still in Europe. and we are still the headquarter for the innovation and for all the technologies, new products for the Hanwha company, and all new products are more or less developed in Thalheim in our facilities and spread to our production facilities all over the world. And Q-Cells, of course, is a global player. We have manufacturing facilities in Asia, Korea, China, Malaysia, and in the United States. Currently, we are establishing a second factory in the United States, which is along the complete value chain. This is not so important for the pepperoni project. Also this one, I think no need to talk about too much about this. Yesterday there was a quite interesting, I think it was in a panel discussion, that especially for some markets, like maybe the residential market, the price per watt peak is the wrong metric. You should better look on LCOE instead of price per watt peak. And this could be also one of the parts of the projects to spread to the public what is the right metric to look at in terms of bringing in new products which might be more expensive in the beginning, but in the long term in LCOE are advantages. Our current standard is the TOPCon technology. We call it Quantum Neo. I would like to focus on the right-hand side, the learning rate. I mean, I saw this several times today, but not with our numbers. You know, cell conversion efficiency over the years. So we managed to keep the 0.5% absolute efficiency increase within the last 1.5 decades for 3 different technologies. And to show why pilot line in the beginning is a good idea, is actually this one. We have in our pilot line in Thalheim a quite narrow distribution of the efficiency on a quite high level. So median efficiency of 25.3% and the best cells over 25.4%. And if you now consider also the manufacturing distribution, which is the hatched columns, it's quite overlapping perfectly. So it means starting in a pilot line, having all the learning processes, and then transfer to manufacturing makes absolutely sense. And even in the mass production, we have median efficiencies of 25.2, which is not too bad, I would say. And of course, it's not only cells. One of the champion modules we made out of the cells, this is still M6 wafer size, was over 440 watts and 24% of efficiency on aperture area. But then the question is, what's next? As standard mature technologies saturate in terms of efficiency, and how to keep this learning rate of 0.5% or even more in the future. And one of the first cooperations we had then with the Helmholtz Zentrum in Berlin is to use our quantum-based cells as a bottom cell and, simply said, put perovskite top cell on top, make a tandem cell, and at least on a small scale, we could achieve then 29.9%, which was also externally certified. But as you all know, and we have seen a lot of talks and discussions about perovskite tandems, there is headroom for over 30% with this technology, which makes it quite interesting. And also I saw a very nice slide this morning with, I think it was 26 or 27 points, which have shown the hurdles and challenges coming along with perovskites. And also perovskite has to compete with mature technologies, and we have to achieve all these achievements we already have with the standard technologies. We need to have high efficiency in industry, and not only in industry, but everywhere. Low cost is very important. High manufacturing yield comes along, low cost consumables, and so on. And of course, one of the biggest points is the long-term stability, especially for the perovskite silicon tandems. And in Fabian's perfect world, we would utilize ideally all the production capacities all over the world to make not only PERC and TOPCon, but let's not say only tandem, but future more high-end technologies, just to speed up the energy transition. And after this cooperation, more or less, Pepperoni was initiated. because you cannot do it alone. You cannot do it only with two parties. You need experts and expertise all along the value chain to be successful, and to be successful in a quite short time. And yeah, that's when Pepperoni was initiated. And what's Pepperoni? It aims to spice up cost-efficient industrial silicon cells with a perovskite top cell. So making a tandem cell and finally put this tandem cell into a reliable module product. And in Pepperoni, we try to set up finally a pilot line manufacturing tandem modules and bring it into the market. It's also a project with a big network of partners, 17 partners from 12 different countries all over Europe. We started already in November 2022, so we are at half time now. It will last until 26, and this is the partner network. So we saw a lot of these cards already, or these maps. And it's not the complete value chain, but at least a big part of the value chain we have here, and many partners from research and some from industry, especially equipment suppliers, material suppliers, and finally we as the module manufacturer. And one important point we saw in the talk before, I think, is especially doing this analysis and also spreading all the information into the community, social aspects, environmental impact, and so on and so forth. This is how it's set up. So we have a big bunch of researchers and research institutes and partners. All are very well known. And then in the industry, equipment manufacturers for the cells, equipment manufacturers for the modules. I just recently saw a talk about edge compression, so it makes sense to also have maybe develop tailor-made module manufacturing tools and also cell manufacturing tools for the special needs we have. And finally, transferred into the pilot line in our facilities in Thalheim. And actually, as said, we are already at halftime, so most of the tools are set up and are running. And as we start in the project on a quite small scale in terms of wafer size and module size, which makes sense because you can have a lot of statistics on development, we tried now to transfer it to M10 wafer size and large module level. I mean, the first point is quite clear. You need to have best ratio performance over manufacturing costs. So again, coming to LCOE then, you have to have a reliable product. You have to have a reliable product which is not too expensive so that you can convince the customer to purchase your product. And this is also a point you need to consider before. What is the desire of the customers not to develop in a direction and then sit on your product and cannot sell it? It's divided into different blocks or work packages. Of course, a big focus is on the cell development. As said, the bottom cell will be provided by Q-cells with our quantum technology, and all the other top cell developments, many partners are working on this. And as said, also for the module manufacturing, because especially for perovskite tandems, a big focus is on the cell development, which is quite understood, but as I'm a module guy, I can tell it's not so easy to put these cells into modules and get the same power output as the cell guys want to have. So also the module side needs to be considered, and it's quite good that we have a lot of also module manufacturing partners in the project, so that we are quite closely cooperating to improve all the machines and tools. And finally, we need to maximize here tandem power conversion efficiency. Of course, again, said stability, durability, a very important topic. And finally, a reasonable production yield in the pilot line. This is the overall work packages, so the technology development on the cell processes, then as said, on the module integration. We had to develop several manufacturing tools, and of course also materials are part of the development. And now, as said, we try to scale up on M10 wafer size and large module size. Then everything has to be tested, indoors, outdoors. Outdoor data is very important for bankability and so on. And again, economic, environmental, and social aspects becoming more and more important. This is also a big part of the project. We have quite good partners here. We have a lot of social media postings to spread the good idea and the aim of the project into the world and into the community. And finally, I repeat myself several times, so put it into the pilot line. And of course, along the way, during the development, when you have innovations, also to protect it. There was a discussion also yesterday. Sometimes it might be not a good idea to apply for IP, because this maybe slow down the development. Better to start directly. But there was not so easy, I would say. I prefer to protect what you develop and do the development in parallel. Here we have the opportunity that we have quite a good IP team alongside, which helps us to secure and save and apply IP for the new developments within the project. I think this slide is already outdated, as there's mentioned that silicon-based tandem cells expected to appear in mass production after 2024. Oxford is already selling modules, so might be a little bit outdated, but anyhow, modules with effectiveness or with efficiencies over 26% expected to be in the market after 2026, according to the International PV Roadmap. And Pepperoni will increase cell and module performance and optimize manufacturing processes for the tandem technology to speed up the market uptake. And here is the timeline. As said, we are right in the middle of the project. We are quite good on track, I would say. And if everything runs smooth as it runs now, the pilot line will be set up completely and process will run by end of 2026. And then hopefully we are also 1, 2, or maybe even 10 steps ahead in terms of stability and reliability of the tandem, perovskite silicon tandem cells and modules. That's more or less it. Here are the contacts if you want to get in touch with the Pepperoni project. As said, Fabian is the technical development coordinator. Bernd, he's also here on the conference. Not sure if he's here in the auditorium. As the project coordinator, and Joanna is the communication manager. You can reach out on Twitter or X, on LinkedIn, via internet, or just drop an email if you have interest in further information. And with that, thank you very much for your attention.
Thanks, Ronny. Are there questions to this presentation?
Yeah. Thank you for the nice overview of your project. Maybe I didn't catch it, but thank you for this nice overview of your project. Maybe I didn't catch it, but what are your main goals? Is it efficiency? Is it certain pilot volume manufacturing? Is it module stability? And you have 2 years of product now. What did you achieve meanwhile? Can you comment a little bit?
Everything what you said. So, of course, there's no real target, I would say, in terms of power output or efficiency, because this depends also on the module size. I think this is more or less belongs to us or to the market requirements, as said before. But pilot line sizes in the project, I think it was 200 megawatts, so quite a decent size. And this is the plan. And module manufacturing tools, cell manufacturing tools are able to fulfill this plan. And as said, now it's just a little bit more automation, process improvement, and then get the stability. This is the biggest task. Does this answer your question?
Yeah,
thank you.
So it sounds like the main plan is to implement the line, right? And in the end, you will have the first results for it, right?
To set up a pilot line to show that tandem perovskite silicon tandem manufacturing is possible in Europe.
Okay, thanks. Okay, thanks a lot again to the three speakers for your presentations on these EU-funded projects. Maria, when you learn about these projects, what comes to your mind? What do you think?
Okay, so it is nice to hear what these projects are about, because the topic actually that we launched and from which the projects resulted aimed at developing, yes, pilot lines, but for technologies which are innovative and for technologies that can compete in the international market and that bring a technology advantage or a competitive advantage in Europe in order to be able afterwards for the participants of the project actually to commercialize this technology. This would be the first step. So a pilot line is the first steps for the commercialization of a technology. That was the given, that was, sorry, the objective, if I go and read, which were the objective of the topic. So I hear, yeah, very interesting projects, and I hope that by the end, actually, of their term, of their time frame, of the end of the project, they will actually deliver not only the pilot line as a physical, I mean, as a pilot line, but what goes with it, which means, and that was the question, which are the targets? The target should be also a technology with X efficiency, with X lifetime, so something that would be competitive in the market. And of course, this has to be demonstrated at a pilot line level. And as I said before, there are afterwards next steps after the pilot line that can bring the technology to first-of-a-kind demonstration, for example, or if this is not, the wanted, then to commercialization directly. So it's like a function. You need to optimize a function which has several variables and unknowns, and you are trying at the end to have a product which is optimized, which means it is cheap, it has a very high efficiency, it can be competitive in the market, competitive compared to other products which are already available. Or not personally, the projects target a specific market and they define which are the requirements for this specific market in order, by reverse engineering, to develop what they would like to do. So I think, and I hope, I hear that the projects have very clear technology targets. I mean, they know very well where they are, what they are doing, and I hope that by the end of the project they will develop something which is competitive as well and which corresponds to what they have promised, actually, that they will do.
Excellent, thanks. From your comment, I would assume you're a trained mathematician, is that correct?
No, I'm an engineer.
Oh, you're an engineer, because you talked about the
I'm a
analysis
chemical
of the function.
engineer.
All right, okay, close. Gaëtan, the Becquerel Institute is into market analysis, and it has very often a global perspective. How would you rate these projects? Do you think this will deliver results which are competitive on a global level?
I will first try to forget that we are involved in IBC4EU, because otherwise I will going to say that it's the best, of course. I'm more preoccupied by what you're saying, Maria. Because when we're talking about competitiveness, I fully agree about the statement that it's LCOE, which is the metric that we have to consider and nothing else. For the time being, we are in a situation on the market where nothing is competitive with the price at which our Chinese friends are selling. So I'm going to repeat a little bit the situation in which we are, and that will, in my opinion, last for at least 1 year, probably 2, until some actors are disappearing from the market. The spot price for PV modules is about $0.10 per watt. The reasonable cost at which the Chinese should sell to make a 10% margin based on all the information that we know. It's in between 18 and 21, 22 US dollar per watt. So we don't have to say that we already have a problem. So I will try to compare with these two last numbers, not what exists on the market. Now, my problem, and that's in terms of market analysis, is that I will talk about the Net Zero Industry Act in Europe in a minute. But if we are looking at the market segments where the questions of efficiency, I'm thinking about IBC4EU and Pilatus, where the questions of efficiency and aesthetics have an importance. It's basically the residential PV market. All the rest is driven by cost, and it's driven by cost because in the last 10 years we have been make sure in Europe that it should be like that. So we have pushed for tenders where the most important element is the cost. So, of course, if you are the cheapest, you win everything. So if we are looking at the residential PV market in Europe, it's something like 1/6 of the market, so something like 10 gigawatts. It's not that bad. That's what exists. And on this market, indeed, there is an appetite for what is done in IBC4EU and Pilatus. I'm putting pepperoni apart because I appreciate a lot your timeline, which goes until 2035. And I will not comment on that, but yeah, 2030, 2035, it's not what we are going to discuss immediately. And then I really think we have here two interesting technologies, HBC and TBC, which might have a tremendous impact on the market in Europe in the coming years. Not because of the residential PV market, but because we start to have a framework for local manufacturing. And in that case, the cost difference that we cannot compensate for the time being might be compensated by a certain number of other aspects that these two technologies might fill.
Okay. We will definitely come back to the Net Zero Industry Act and how we can establish PV manufacturing. But we pause that topic for a moment. I would address again more the technical parts of the product design part. Hamed, you're a specialist in choosing the right technology for the right application. Where do you see there were proposals for the applications of these technologies? Would you agree? And do you maybe see additional opportunities?
So first of all, I should say most of the things I wanted to say already said. So, but firstly, we have to look into the market. Again, I would like to start with the first two projects for IBC projects, and maybe a very minor correction to the prices. At the moment, the price of a double glass TOPCon module in the market is about 8 cents in case that you want to buy it in a small quantity. And if you want to buy it in a large quantity, we come to about 6.8 to 7 euro cents. Okay, so it's even lower at the moment. And this is a big difference because in case that we want to go for applications of IBC, we have to firstly consider the cheapest available product in the market. And that cheapest product is at the moment for a rooftop, as Tom mentioned, which is the main target for IBC because the customers like to see the module black. This is the wish. So efficiency here doesn't matter that much. In case that is 1% less efficient, no problem. But it should look black. But this is only limited to the rooftops which are tilted. Okay, it doesn't apply for the flat rooftops because there the customer tends to pay for the module which has white spacing because it's not going to be seen in any case. The advantage of IBC is the aesthetic and people pay for it. And now if we want to compare the prices, we see that for 10 kilowatt system, the price of the module is about 700 euro. Okay, so here is the chance for IBC for that specific segment that in case that is more expensive, but it looks appealing. And in case that, for example, for a European customer, you say, okay, I can make this for 12 cents per watt peak, almost twice. At the end, it's going to be 1,200 euros. So they're, I would say, willing to pay this premium to get it. So it's a chance, but in case that we could do it in Europe for 12 cents per watt peak, which in my opinion is almost impossible, at least for the short time. I would.
In China. I appreciate you for many things, but I have to correct you. I'm taking the financial reports of Chinese companies for the time being, and I'm taking Jinko Solar, which is the most competitive one of all. Jinko has a cost in China per watt at 12.3 US cents per watt last quarter. And Jinko is selling at 14 in average selling price in their financial reports. So some are selling at 6 or 8 cents because they absolutely need to make cash, but a company like Jinko is selling in average at 14, and they are losing money. And they're losing a lot of money. And 12.3 results from two elements which are totally unsustainable. The fact that polysilicon on the market for the time being is sold at a price which is below production cost. That's something which is relatively easy to calculate. And you have the same problem for wafers. And basically, if you take just production cost without margin for polysilicon and for wafers, you are bringing the minimum production cost in China around 14 to 15 US cents per watt. And that's production cost. And in addition to that, you have to count SG&A costs, R&D, financial cost. And when you put that all together without transport cost, you are minimum at, without margin, at 17, 18 US cents per watt. And then you need to do a margin because the company has to survive. So the comparison point that we have to take is a sustainable Chinese industry. And then we might have other ways to make sure that we will have a fair competition. And I finish by that. We still have a significant competitive disadvantage because of labor cost, because of the fact the value chain is not developed. It's impossible to source glass at a competitive price in Europe and so on and so on. But I think we should stop saying at some point that what we see on the market corresponds to a sustainable market. Many Chinese companies are going to be bankrupt, and they are losing money in the hundreds of millions for the time being. I'm sorry, I cut you.
No problem.
Yeah.
But maybe...
hang on. Hamid, Maria wanted to add a point, I think.
Not at a point, but just to clarify that when I'm saying competitive, it does not mean that we compare it now to the price. We are talking here for pilot lines, which we will deliver a competitive product in terms of various functions for various, how can I say, from various aspects, but it is not the price. Currently, yes, for one reason or another, the price of PV is very low. When we say competitive, it means that it has a good behavior in its environment. For example, it is very good for integrated applications. That's one category, for example. Or it has a very high efficiency, or it can be produced in low cost, but we don't compare it, or I don't want to compare it to the prices of PV that are sold now. This is not, I guess, a fair comparison for the reasons that you have mentioned. But this does not mean we are going to stop whatever we are doing. So if we say that, okay, now the situation is like this, we will not do anything, we close the shop, we don't do anything in Europe, we don't do research, we don't do anything at all, and we take this fatalistic, let's say, attitude that we cannot compete and we do nothing. But is that what we want? Or is this what we should aim to?
I'm happy to take your point or your opinion in a second. I think we have a topic here, and which I would like to address to the audience, which is do you want to continue, let's say, on the macro picture, on the political aspects, or do you want to also switch back to the projects themselves, or maybe go back to the projects and then maybe take the last 10 minutes for the macro aspects?
Yes, to the
So stay with the macro aspects. Raise your hands. Give the that's how many? Please, all the way up. That's 1, 2, 3, 4, 5, 6, 5, 7. Who would like to give the projects time to comment on their learnings, etc.? 1, 2, 3, 4, 5, 6, 7, 8. All right. So let's do that. And 2 more. Others from here. And but I'll definitely. It's not that I don't think it's important. In the opposite, but I think we just I just try to get a balance here, okay? And so it's 6 minutes after 6. So let's say we spend 10-15 minutes now on with the project teams, and then switch back to the political macro aspects. Okay.
Thorsten, I didn't finish my talk as well.
All right, you got 2 minutes.
Yeah, I think I need even less. So for the prices we discuss later, I will not bring it because I know how much we sell. But regarding to the applications, as I said, the main feature of IBC is aesthetic. So we have to, we can give a beautiful module which looks homogeneously black. And with the current prices that we see in the market, it opens a lot of niche markets. This means that PV is going to be used everywhere. So it's going to be used in, for example, balcony modules, for fences, because in case that you go to the, I don't know what is Baumarkt in English, but where you buy the building structures and...
hardware store?
Sorry?
Hardware store or something?
Not hardware, but for building materials. Then the price of the module is cheaper than the price of fences. So you can put it also as a fence. Therefore, lots of interest gonna come to have a beautiful design from the aesthetic point of view. And I think this opens a lot of opportunity for implementation of IBC more and more into the environment.
Yeah, excellent. It was 2 minutes.
Yes. And I would like to take this shortly back to the price. We did the calculation if we did the...
Can we push that to the end, to the because we just had the
no,
and we want to switch back to the project.
Just 30 seconds.
You insist on it, all right? You go.
No, it's like we did a math calculation that is it would be 16 cents about production costs in Europe if we had a 5 gigawatt greenfield factory. So we are not so far from the Chinese manufacturing costs. And I think that's also a big part of the project, in fact, to determine the techno-economical aspects, so therefore it's close enough. But I think just that hit back to, we would like to do that if someone would be able to fund this factory, which would be about a 9-digit sum, I guess, if it's fully integrated. So it's not that even it's impossible to produce at a similar price. It's just very difficult.
Yeah. All right.
But then maybe I have a question. Where in Europe for 16 cents? I cannot believe that.
Well, I guess it's Joris is not here. He did the math. I think it's a low electricity price region, next to the hydrostatic power plant in Norway or something. Maybe not Norway, but Sweden. But yeah, it's not. Let's say it's not fully impossible. You can do the math with a sharp pencil, and you should be able to produce that at scale. But getting that funding, good luck with that.
I also have a comment on, let's say, the macro picture, but I'll keep that for the moment because I think we wanted to do that at the end. Gisem, how would you rate now on the global competition the results you have achieved so far, and what would you say is the most important learning that you have learned now in your project?
In terms of technical results, or
you choose. Yeah.
The most important learning in the project, I think it's So I think in terms of technical results, we are quite in a good position. So.
Could you give us figures from, let's say, what are other world record numbers or record numbers from, I guess, most importantly, China in comparison to what you have achieved?
I mean, yeah, of course, Chinese modules are more performant. If you look at the ICO Solar's IBC modules, they are amazing. So I cannot say that we are doing better than them.
Yeah. What's the gap?
So the gap is quite a bit, let's say. I cannot really specify the number from my head. But yes, we still have some way to go in terms of technical developments. But it's a promising technology that can be produced in Europe. And But there are other aspects, I mean, that we learn in the project. So in 2021, we started to write the project, and you try to see what will happen in the following 3 years, and you try to plan the pilot line in terms of trying to see what could be still relevant after 3 years. And we see that in the PV market, everything is changing quite quickly.
Yeah.
So, and in very quick time, you can be really obsolete with the project proposal that you write. That's granted. That's like rated very highly. So, of course, we still try to stay relevant. But I think what's most important is to keep the agility of the project and try to modify as much as possible with the market development.
Yeah. You just mentioned the gap to ICO Solar, I think ABC, they call it, right? Yeah. Do you think the gap can be closed once your process would be brought into mass production? Because I myself made the experience, I think Ronnie can confirm that once you go into mass production, you showed that mass production has a lower average efficiency, which is surprising to me. Maybe because the pilot line is so good.
Only 0.1%. So.
0.1%. But do you think that with more experience, this gap can be closed, or is there a fundamental difference to the ABC?
I don't think that there's a fundamental difference. It's in Europe, when we do one experiment in time being, in China, it's possible to make, 200 experiments to optimize the design and the technology and the module, everything. So they are much faster to optimize, to improve than compared to our capacity that we have in Europe. Also, it's basically the statistics. If you do more samples, then you have a much better chance to improve the efficiency of the cells. And I don't think technologically there is a fundamental some fundamental limitation you can achieve what they are achieving there. We just don't have the capability to do as much test as possible, and also the speed. Speed is always the thing that in China they are amazing. So
yeah, excellent. Thanks, Florian. You outlined the project, and you have many industrial partners. You have equipment makers, but you also have, I think, module makers in the project, right? So what do you think is the best result, utilization at the end of the project? Will it be a process transfer to the equipment makers, or do you straight go to transfer the technology to a cell module manufacturer? What do you think is the best approach here? Or what can you deliver at the end?
Just coming back to Gizem's point before answering your question, I think the great gap that we have in Europe is actually that the advantage that QSATS has, having a running pilot line to optimize the process even better than in production, but otherwise it's really difficult, as she has really correctly said, and the same we are facing as well. For the cell technology that we are developing, our major customer would be anyone interested in licensing the technology and producing it, because that would also help our module manufacturers that have a focus in back contact technology. They have been using MWT cells or whatever cells they could get. Those are really difficult to source. So we would, if we found someone to really invest in such a factory or take us into, for example, a TopCon factory where we could pilotize it, optimize it, and then actually go into mass production to close that gap to ICO and the others. That would be great, because then there would be availability of back contact cells on the market. I mean, I think if you want to buy ICO cells, it will be very difficult if you want to produce modules from them. So it would help to build like an ecosystem in which you can buy cells from maybe more than one manufacturer, and then create a sustainable module production there as well on either of the technologies. So I think the ultimate goal would be to really get a lively IBC community, and therefore it's great that there's another project also working on IBC, because I think a lot can actually be used.
So is it correct that you could transfer the technology at the end of the project straight into a factory?
That's the goal, yes.
Yeah, excellent. Good. Ronnie, there was already the question, what do you actually want to achieve? So the key target is to establish the pilot line. So there are no other targets. I ask again, right? Because one thing is to set up equipment into a factory, but what about other targets defined for stability and the, let's say, champion efficiency, which I think would be classic project targets?
Yeah, I mean, champion efficiency over 30% in best case, right? And
that has been achieved. What would be different? Is it high throughput or?
But not on a large scale. And even if you consider modules,
for a module, you mean?
That would be nice, right?
Certainly, but so I'm asking you, what's the target, right? So
the first target is to set up the pilot line production.
Yeah.
To show that it's possible to manufacture perovskite tandems in an industrial environment, but to, as you know, and as we all saw here on the conference, the biggest challenge is still stability. So you have to compete, or you have to be compared to the standard products, and that means at least 25% of warranty, 25 years of warranty. So to achieve this with a tandem module, this is at least to me the biggest challenge at the moment. And
in this project, are you looking at alternative materials rather than that's included in the Pepperoni project?
It's included,
which are maybe inherently more stable than
on cell level and on module level. Yeah.
Yeah. Okay. All right.
It needs to be. I mean, everything is completely new, and all the interactions between the materials are not fully understood yet on cell level, nor on module level, nor on the interaction cell and module materials. And this needs to be understood. It needs to be stabilized, and on a very high level of efficiency to achieve best SUE. Although we are not talking about prices, but I mean, finally we have to talk about prices. And although it was said we do not talk about $cent per watt peak, it was talked about a lot about $cent per watt peak, but we need to get to this SUE discussion.
Yeah, excellent, good. I'm happy now that we gave the projects a chance to give more details. Are there any questions from the audience now? I'm happy to switch back to the macro political level. There was the first hand was there on the left on the corridor.
Thanks. Yes, a question that maybe covers the gap in between both aspects. How do we choose technologies? I'm thinking, for example, in the Pepperoni, for maybe the evaporation, the position of perovskites. If we don't make the standards anymore, and China has a bit of advance, how we show that we don't build pilot lines for technologies that might be outdated because China moved to bigger cells or decided that evaporation was not good for perovskite, and we should go back to spin coating or whatever.
There was a quite good idea from Gianluca Coletti yesterday. In the past, we sold manufacturing machines to China, and they ramped up lines and maybe, I don't want to say copy, but we should maybe do the other way around and purchase the state-of-the-art tools from China and put it into our pilot lines. Why not? So if this is the case, we heard before that I saw some numbers of LongG. So 4,000 R&D engineers and 800 working on perovskite tandem. I mean, in Thalheim, I don't know, we are 60, 70 or something. So that's why we need big networks of partnerships in Europe. And even, I think we need to get more close. Bigger, all expertise has to be in maybe one large European manufacturing project.
So you are proposing stronger collaboration within the European Union?
The biggest advantage we have, yes.
Yeah, excellent. Gaetan, I saw that you wanted to say something, but there was someone in the audience. No, stop, please.
I'll say it very fast. The problem in the question is the fact that indeed, since we have no large manufacturers for the time being, we are unable to follow the speed at which the Chinese are going for the time being, and it's valid also in terms of standards. They are defining module size, they are defining module design, they are defining wafer size, and they're changing it every 2 years for the time being. So indeed, the only solution will come from European manufacturing and standardization imposed by regulation. Mm-hmm. There is a significant work to do on that side at European level, not only eco-design, but we could go significantly further in order to have our own way of imposing what we want to have.
Okay, so it's a collaboration and standardization. Excellent. You've got the microphone.
Peter Hacke-Enrel here. My friend Eric Eichelboom over here tells me he has enough with macro questions, but I'm sorry I have a macro question. So one of the gentlemen on my left, Mr. Masson and Mr. Hanifiek, sorry I can't remember, said that the prices in China were unsustainable and eventually that would have to end as some companies would go bankrupt. Can you comment on the timeline for that?
There is a very easy way to say it. Companies, even in China, have cash reserves. It depends how much you have and how much you are losing. And some are better placed than others, but I would say 1.5 years to 2 years.
I think it's started already. So maybe you can check the status of the company Acom Acom. Yes, so they already, I think, went to that phase. We also heard a lot of news from other big companies that they fired a lot of staff. So this shows that actually it's already started. Just imagine that it's over a terawatt production capacity there, but there is not much of demand anymore. So everything is still. And with the prices, again, I want to correct maybe the prices of Gaetan is not that up to date. But for the prices that I have from September, from what we selling, is at about 8.4 cents if you are ordering a very small quantity. So if you order more megawatts, we can even go above 10% discount. So it means that we come to 7 to 8 cents per watt peak, euro cents. Means that you hardly can make a margin, okay? So you're surviving basically at the moment. And this is more severe for the Chinese companies at the moment. So it's not in a way that we're talking in the European level, it's no chance here. But even in the Chinese, the trend is already started. Of course, the politics can change the things in China because they get a lot of subsidies. But the market pressure is very high, it's very, very high. And I think the trend is already started.
Any more questions from the audience? So it's 6:24. I don't know if you manage to give everybody the chance to have a final comment. Which one do I choose? Does anyone want to say something on top?
I can say some small things. So what Maria was telling about the establishment of having everything in Europe, of course it requires policies from EU. for protection because, and also the other aspects, as Gaetan mentioned, that we have to really have regulations because, of course, changing the dimensions and everything going to bring in the future more problems when you do repowering projects, when you want to do replacements. So this is all a matter, but at the end of the day, we have to consider that the big projects, which are the drivers, are being, through the investors, the people who buy the modules are the procurement people. So they just want the price and the certificate. Okay, this is what they want to see. And therefore, this is why that the price really matters for any cost. So even with tariffs, with regulations, with subsidies, but this is a defining way. And for funding of the factories, it was also, again, a discussion from Florian. I think that the financings to some extent, the fundings can be done through a different way of funding schemes. But the point is that at the moment, the banks have also no interest on new production lines. So they find it very risky compared to China, and they don't want to finance any production facility. So this is again coming back to the politics and to the market pressure. So many other things, if a company wants to start a production, even a newer product which has a higher risks, we have to consider that this is a factor to be considered. And a final small thing was about the pilot projects that we heard about. So I think that not only a pilot line, but also a pilot project is necessary because if we want to go for mass scale with new technologies, in case that we can produce them in Europe, we have to consider that there is a high risk and investors in the beginning are skeptical. Insurance companies will not insure the projects because they don't know how is the long-term in-field status. So I would say that it takes a little bit longer, especially when we're talking about perovskite, tandem, solar cells. So I wouldn't be sure that, for example, when we're talking about Oxford, that they're putting in the market, whether it can go really big. So this is something to be considered because at the end, it's the mass scale which defines the market.
For the R&D, I think we got the nice term collaboration. On the product design side, we got the term standardization. What I'm lacking now is a very simple word for how do we create a market for the European products. Is it a reserved market? Gaetan or Maria, do you want to comment? And this, I think, would then be the final reply. Ladies first.
To be honest, I do not believe, or I'm not sure whether when we define or make specific standards or specific choices, let's say, for the European market, that these will favor European manufacturing. Anybody could conform to these standards or to these requirements, and therefore they would not favor, or they would not favor their purpose, which was to support European manufacturing, if this is what is meant by the question.
If it's 100% produced in Europe, then there's no labels, it's just a certificate of origin. Yeah.
Yes, but okay, I don't know how does this conform with the...
Do you say WTO?
Yes, exactly.
Who cares about that?
Well, if I don't care, there are many people who care, and we cannot work like this. I mean, yeah.
Okay, but John, do you have a solution?
However,
or you, Maria, you go. Yeah.
Maria, finish.
Yes. However, I know that under NZIA there are, in order to have the resilience, or there would be criteria which relate to the resilience of the value chain. And therefore, in order to support the resilience of the European value chain, there will be criteria which will be relate to the country of origin, or there will be, in any case, non-price criteria in auctions. So these non-price criteria will be defined, And therefore, for one reason or another, in certain auctions, and when the percentage is of the offers is enough, those criteria, non-price criteria, could be selected in order to support, for example, European manufacturing or other sort of non-price criteria.
Okay, so you
So
would...
there is the possibility, actually, to have non-price criteria in auctions in the future, and this is defined by ENSIA. And these non-price criteria will be defined, of course, by the member state, or, yeah, that's the auctions.
And so the third term would be non-price criteria in special auctions, which is a bit long-term, but I guess that's...
Well, I don't know how it will be. Perhaps Gaetan knows better. No, I don't know how it will be called. But in any case, there will be these non-price criteria. However, one needs to have enough offers in order to comply with these non-price criteria. If, for example, there are no offers that comply with, of course, these criteria will not be respected.
Yeah.
I can try to complement that in 30 seconds, and I would like to make another comment in 30 seconds. So I'm more positive because as the European Solar Manufacturing Council, that I'm still co-chairing, has been heavily involved in the discussion. And if you really want to spend your nights reading the Net Zero Industry Act, it's 120 pages, and I can tell you that it's not easy to read. There is really a possibility to have up to 40% of the European market in 2030 reserved smartly for European companies, if we have companies. And the Commission has done things very smartly. Now it's up to, as Maria was saying, to member states in 2025 to implement that properly. So there is a change. And we did it in a complex way because it's our way of working in Europe, but at least there is something. In addition to that, as I was saying, there is the residential PV market where there is a willingness to pay for made in Europe.
Okay.
And now I would like just to comment on the three projects before. I'm not commenting on tandem with perovskites, and I will not make friends with Oxford PV, but their product is not ready. For IBC4EU and for...
Well beyond 30 seconds now, Gaetan.
No. Yeah, okay, 10 seconds. I think, and we haven't talked about that, these two projects have worked on something which is essential. It's the reduction of silver in PV cells and modules. And significantly, and in my opinion, the two projects are in advance compared to what China is doing for the time being. And back contact requires a level of technology which is not reachable by most Chinese competitors today. ICO is 10 cents more expensive than the other competitors in China, even if it has the best technology. And LONGi is having incredible technical difficulties to ramp up production of its back contact cells. So here we have two technologies which have a real potential for manufacturing in Europe. Yeah. It was a little bit longer, but I want
a little bit longer. Florian, sorry, I'm sure there will be a workshop soon where we can continue that.
I'm sure.
Maybe online. I'm sure something in Constance or so. I'd like to wrap up. So it's about collaboration. I like that. I like. I'm not sure if I like standardization, but maybe that's anyhow a possible way forward to help at least us in Europe. And then I'm super happy to hear from Gaetan and Maria that ENSIA offers these new possibilities, which are, I assume, WTO conform, complying with the WTO regulations. So we will see member states in 2025 going for national law, and then we're all set. So it seems there's hope. Thanks for your attention. Hopefully we'll see you at the conference dinner. Bye-bye.